Welcome back, everybody. Part 2 here of the Audio Research SP-3-A preamplifier, Phono preamplifier. And if you'll last recall where we left off, we were putting together what I call a BOM, a bill of materials, and we were placing several orders, one with Mauser, one with Tubes and More, and otherwise known as Antique Electronic Supply. And we've got our got all of our parts in at this point in time. And I was doing what any good inventory person would do, and I'm checking the things off of my BOM as they've shown up. And you know, we've got our big capacitors we're going to use here. These are the Panasonic 330 microfarad at 400 volts. We've gotten in our F&Ts, which by the way are fantastic capacitors. These things are made in Germany. 100 microfarad plus 100 microfarad, so 200 microfarad sections in here. At 500 volts, we're going to be using those. We got our 1500 volt at 63 microfarad. These are Panasonic as well. You can see that little M on them right there, and the M on that right there, that is the Panasonic symbol these days. We've got our Solene audio coupling caps we're going to use, quite a few of them here. A couple range drops for some spaces where the Solenes didn't have the correct values. We've got some WEMA caps here that we're going to use in a few places on this thing. And then I got to the resistors, and I started going through. You can see here there's a big stack of packs of resistors here. And you can see these are the carbon composite resistors that I got. These are actually the Kama brand, K-M-A-Y-A. And I was sorting through all those, making sure I got all the right one. And you know, there's lots of sizes. And then I got down. There's some Dale, Vishay Dale Precision 1% resistors that I was putting in the bias portions of the 12AX7s. And I happened to notice, you know, hey, those are pretty good size. They're half watt. And then I came along, and lo and behold, what did I do with it now? I think it's right here on the very bottom. Nope, not there. Well, over here on the other bench. Turns out I made a mistake, and when ordering I got 100K 1%, and instead of the half watt I got quarter watt Vishay Dale 100K precision resistors, and they were such a special price. I only needed 8 of them, but I ordered 50 just so I'd have them for next time, because 100K is a pretty common value resistor that gets used. So hey, these won't go to waste, but cannot use those because they are 100K. They are quarter watt, and I needed half watt. And I happen to have a friend who I reach out to from time to time. He sells kind of low quantity stuff like this on eBay. Anyway, these are some 100K 2 watt, and instead of 1%, these are 0.1% precision military spec resistors. So I'm going to use those instead. Picked up 20 of those. I think it cost me about $10 with shipping to get them here. But what I didn't want to do was go back to Mauser and place an order for just 8 resistors. They ding you pretty hard on a minimum dollar order, minimum quantity, and shipping. You'll pay as much of it for shipping as you do the items. And then you can see these resistors right here. Those are the ones that we talked about them. They're the ceramic composite resistors, and they're designed to be fairly tolerant to changes in voltage, surge voltage, so these things don't burn up very quickly. And we got those for the power supply section. You can see I got a lot more carbon composites here, but let me take you and show you the BOM and where I messed up. Alright, this was my completed spreadsheet, and I kind of had a running list here of how many I needed of everything, and then kind of a number of how many I ordered, because sometimes you got to pay attention when you go to order 4 of something. Well, you know, you might want to just go ahead and order 8 because there might be a price break at 8 or 10 or something like that, where it's just as cheap to order 8 as it is to order 4. Sometimes it's actually even cheaper because the price per quantity goes down enough that ordering more gets you the same price or better. And let's find here the 100K resistor right here. I needed 8 of them, and I ended up ordering 50 of them because they were dirt cheap. And comes over here, and wow, right here's the number: 71 CFM 55100K00FHEA. And if I look over here at the at Mauser's website, at the half watt 100k ohm Del Vichy resistor, it's the same number but it ends in a B. So I have a number off by 1, and I know how I did that. Sometimes when you're looking through these parts on the website, it's easy to scroll down just a little bit too much, and look right there. There is the, I probably saw, oh, okay, 100k, 1%, Del Vichy, that's what I need, and I ordered the A, but I missed the little part right there about the 1/4 watts. So pay attention, double check your orders. It happens to the best of us. I mean, this is a pretty long order that I had going here. Let's see if you can see, there's still a good bit more to it down here. I think this whole order in total for the yeah, this whole order right here, believe it or not, this set of stack of parts, capacitors, this and that, whole order was about $350, believe it or not. You know, these coupling caps are not cheap, etc. So I ordered a few extra in some cases on these, but still, it's a, you know, it's a hefty size order. So if somebody thinks they're going to completely restore one of these units for $100, I can tell you that the labor is going to be way more than that, and the parts alone are going to be way more than $100. Just a heads up. Okay, I've got the unit turned over on its back, and it's got just a metal plate that you take loose with 1, 2, 3, 4, 5, 6, 7, 8, 9 screws here, and the bottom cover just lifts off. I've already pulled it off and set it aside, but I was going to just document this for the record. Somebody's been under this thing, you know, before, because they've replaced all these capacitors, and you can tell that it's kind of an ugly job in my opinion. You can see circuit traces like that ran from here over, supposed to make a turn and come down here. Well, that trace has been either burned up or ripped off when somebody was pulling the capacitor out, and they've kind of replaced it with this wire, and even this wire right here has solder burn halfway through it. Similarly, I can see a lot of solder connections kind of coming across here and coming across here. I'm going to have to rework a lot of this as I go through mounting new capacitors and whatnot in it. Less than beautiful. And by the way, I do know who did this previous restoration. Their little sticker was on the bottom plate here when I pulled it off, and told me what year it was done in. It was actually done way back in like 2000. Hang on a second. It was done in 2008, and I will not give up the name of who did it. I'm not in the art of slandering others, but oh boy, got dogs barking. I'll be right back. Anyway, sorry about that. The dogs were going crazy. I thought somebody was here, but turns out not. Anyway, most of this front part looks halfway decent. I'm not seeing any major hacks or edits to the original circuits or wiring. Looking okay. This one back here, like I say, it's functional, just not as clean as I'd like it to be, and we'll try to clean that up. What I'm going to do is flip this thing over, and I think I'm going to restore the power supply first, and then stop, make sure everything's working well, and then come back to this. My only hesitancy in that is I know I've got a burn up resistor right here. So I may replace a couple of the resistors here, test it out as is, make sure it's still working, and then go back to the power supply, rebuild it, and then come back to this board. I kind of like to do things in little modular chunks, so if you have issues, you kind of know where to chase it down. But I don't think I'm going to drag you through every single step, every resistor install, every capacitor install. Instead, I'll just stop at a few points, milestones in the journey here, and show you how things are looking. So hold tight, here we go. Okay, we're in here testing tubes on the AR SP3, and so far things are going pretty good. This is a Telefunken tube, and it's testing over there at around 83, and when I test the other side of it here, it's testing up there around 81. So pretty happy with those results. Usually I've got a little system here with these small little labels that go on the tubes, and I'll translate the 80 So the 82 and 81, or 83 and 81 into micromodes here. And then I'll label this tube with GM1, GM2, and put the sticker on the tube. And good news is that's an old Telefunken. It's good to go. I don't know if you guys have seen this setup. It's something I picked up here a little while back, and it's an old Cartomatic. Basically, it's a Western Electric unit here, made by Hickok. And somebody has built this neat little interface where you basically get rid of the punch cards, and instead you've got this unit here that has 57 odd relays inside of it, and it also gives you a couple other tube sockets for like compactrons and whatnot. And then this thing's all interfaced in, and then this box also has a computer interface built in over to a laptop where you can simply type in the tube type you want up here, hit enter, and bam, 2 seconds later it's reconfigured the whole tube tester for you. So you don't have to flip levers, knobs, you don't have to scroll through a book, etc. It really has sped up my tube testing time, and it's a pretty darn accurate unit here. As you can see here, I've got my little label on the tube now. Tells the micromode 1722 and 1680, the date I tested at, and in really teeny letters it's got my info. But I thought I'd show you over here in the trusty old RCA receiving tube manual. I got a few of these laying around the house. But if you look up the 12AX7 here and come over, it'll basically tell you that the 12AX7 is nothing more than a let me find it here. It'll tell you somewhere. Oh, right here. For characteristics and curves, refer to type 6 AV6. So what a 12AX7 is two 6 AV6s in one body. And so if you come over here to the 6 AV6 then and look it up, and then kind of scroll over here to the specs, it'll tell you transconductance 1250 would be a minimum. In other words, if it's lower than that, kind of throw it away. And 1600 is a really good figure of micromodes. So like I say, we're sitting at 1722, 1680. That one's fairly well balanced. That tube will be great to put back in here. And you can see it's an old vintage Telefunken. Let's test a couple more. Okay, this is a new Sovtek tube that was in it. And one side here, if you notice, goes up to about 84. And then if I hold down these two buttons, it tests the other side of the tube. That's what's so great about this thing as well. So we're sitting at 84 and 94 on the readout here. And if you come over here, 84 is 1764 micromodes and 94 is 1974. So that tube's in pretty good shape. Both sides are new. One side's it's not balanced though. One side has a little more gain to it than the other, and we'll label it. I'll go look at the circuit and determine whether it makes sense to use that tube or not, depending on how they use it. I'll give you an example. If one of these sides was the left channel and the other was the right channel, then you may be sitting in a place where you're starting to amplify one channel more than the other. But if like this was a driver stage that then drove the other side of this tube and then moved on as part of a circuit, you might be perfectly fine with this one the way it sits. Okay, continuing on here, I got about half of them labeled thus far. Good thing about these labels, they're vinyl, and they'll peel right back off if you want them off, so they don't they're not papered and stick to the tube like crazy. This tube, on the other hand, let's see, we're sitting here at 42. And the other side of it takes you over to 59. So 42 and 59, that's definitely a bad tube. If I was betting anything, that's the tube that was there where those resistors are blown out, the bias resistors. Okay, we've got all the tubes labeled. 2058, 2058, that one's in great shape. 2100, 2100 in great shape. 2058, 1638, not very well balanced. Probably want to replace it. 1764, 1764, that one looks pretty good. 1470, 1470, it's balanced but weak. 1764, 1974, I'm going to examine where that one's going in the circuit. 1722 and 1680, that one's not bad off, and then that one got a big X on it, it's completely dead. So looking at about 4 tubes here that I'm questioning whether I would want to keep in the amplifier or not at this point. We will see. Okay, up first I'm going to tackle these diodes here. While they're working, just the aesthetics of it's driving me batty. And I'm going to replace all these resistors back in here. Check out how that thing's mounted in there. Gotta love that. Okay, what I'm doing here is I've measured the hole-to-hole spacing on these diodes that I'm replacing, and it happens to be 25 millimeters. So what I basically do is place that right there in the middle. You kind of hold one finger in the middle and use another finger and bend both sides straight down. It gives you a nice, beautiful bend. Okay, we got the all these resistors replaced, nice and neat. Just the other was bothering me, honestly. While functional, was not deserving of this amplifier. Thought I'd show you something else interesting. I've moved on now and I'm starting to replace resistors back here. And I've replaced these 2 resistors here. These were the 2 that were in it. Small little precision 2-watt resistors, and I put back in it what I had told you earlier about the type that can handle some surge and that are really designed to be used in power supplies. And if you see them, if you notice the size difference between them, it's significant. Here, I'll lay one of these down here beside of it. You can see the difference there. But the story even gets more interesting than that. So I pulled out and tested both of these, and check this out. This is sitting at 178 kilo ohms. The one I laid down here beside of this, it actually tested right at 100k ohms. If you look at this on the schematic here, or the parts layout, you got R64, which was this one, and you've got R63, which was this one, the 2 that I replaced. And if you come over here to R64 and R63, in the look here, R63 and R64 are both supposed to be 2-watt, 10%, 100K. And yet we have a 178K ohm resistor stuck in there. So all I can do is beg you to get your amplifiers worked on people that actually care about your amplifier. And we use the correct component values. That's the mysteries I find when I redo previous restorations sometimes kind of baffle my mind. I don't know whether people just insert parts, and if they don't have the right thing, they'll try something else, and if it seems to work, they move on with it. But you know, I'd have to dive in the schematic a little bit, but I'm sure this was affecting things in a negative way. Okay, about an hour and a half into it now. All the resistors replaced here. Capacitor back here replaced. All 4 of these power supply resistors right here replaced. This replaced, and this one actually had a incorrect value in it. Somebody had this little yellow polycap in it, and it was not the right value for what was supposed to be in here. It was supposed to be a 0.05 microfarad, and they had a, instead of 0.05, they had a 0.47, which equates to 0.5. If it would have been a 0.047, it would have been close enough, but they missed it by a whole tenth there. And as you can see now, we've got the nice Panasonic 330 microfarad at 400 volt capacitors in here. These things were quite interesting. They did not go back into the original hole. So like that big hole right there was one of the original holes from when this thing you know, looked like this. But what's interesting is there were holes right beside of that these things fit right into, and I just had to make some jumper wires to go from those holes and the pins on the other side of this capacitor over to the normal spot where they would have went into. And you can see that's soldered a little piece of wire there and brought it through. And similar one on that one, made to drop right in. They fit nice and snug. The holes were perfectly spaced. I've also replaced the let me see here. Those were the 400 volt 220 microfarad that were back here in these spaces before, which of correct voltage, but way too, because remember the originals were 300 microfarad. You drop down to 220, you're losing something. You've lost a lot of power supply capacity there, and on surges and whatnot, this thing would likely sag a little bit. So and then I replaced these two 1500 microfarads, because if you remember, this thing was last rebuilt in 2008, 8 years ago, when these things were put in. These were actually the right size, and 50 volts was with the original, but I went with something a little heavier. I went back in with the Panasonic 63 volts. They run a little cooler. And that's where we're at thus far. I'm going to hit this side of the power supply, and then I'm going to replace these resistors right here. This one's burned in half before I try powering this thing up, and see how it's doing at that point. Okay, I decided on these diodes back here to not replace them. They all tested good, and the traces on the other side are just about shot. And so I did not want to go through the pain of replacing these and potentially breaking solder traces or board traces on the other side. A couple of them have already started to try to pull loose from the board, so I fixed those. But instead I just spent some time cleaning them up, getting them all straight, nice and neat. They actually look pretty good in there right now. They weren't nearly as bad as this set down here that was just aesthetically driving me crazy. I'm not crazy about replacing stuff just for the aesthetics of it, but sometimes my ADD kicks in. But just my better judgment saying these are working, leave them alone, and because the traces on the other side of this board, let me see if I can get around here and show you. Up in here, the traces are just kind of about wore out and shot and starting to pull loose from the board, and there's nothing you can really do to ever fix that other than run wires to replace them, which you really wouldn't want to do. You want to try to keep it as original as possible. So I'm going to leave that way and kind of take it from there. Okay, you remember these traces over here were all whacked up before and missing. Anyway, there's 3 existing holes, one right here, one right here, and one right here. And if you angle the tips of these here inward just slightly, just a little bit on all 3 of them, you're able to get them to fit right in these holes with the negative here and the 2 positives here. And if you'll notice the positive, let me find a little chopstick here. A positive right here was where it was originally at. Actually, these 3 holes are the original 3 holes that were used a long time ago. When somebody replaced it, they used this hole, and if you'll notice, they kind of fed from here over to here with a wire, and then this white wire comes around and comes down here. Well, that's not the way it originally was. The way it originally was is you came off of this transistor leg here, follow the trace down around, and it stops right here, but what it used to do was connect all the way to right here. So that's what I'm going to do. I'm going to come from here to here with a new wire and get rid of this and all the way around over here. Likewise, this one originally started right here and fed around and came around right, or actually fed up through here and came to right here. So I'm going to run a wire from this leg right here, right down here. And then the negative, actually, I bent these over a little bit to hold it in, but they actually line up pretty well right here. I'm just going to solder this one down, and we should be good to go. Show you a little trick. These are all the wires, leads I was cutting off the ends of capacitors and diodes earlier. And I grabbed one of these, like such. Okay, and I started bending it. And I played with it over a minute or two. And I basically bent it around. I started right here where this trace originally ended. I went right through the middle of the prongs here on this capacitor. And I bent it around over here and tied it back into the original circuit trace. So we're basically back to factory original, other than this piece of the trace has been replaced from here to here with a piece of wire. But it looks way better than than the jumper that was kind of in here going all the way across, which by the way was burned halfway in two here on the end. But yeah, I like replacing circuit traces where I can with wires like that, and usually turns out pretty well. Alright, I've done the same thing up here. So you got the positive connected here down to where it originally was. You've got the positive here connected back over to this trace, and you got the negative going to ground right here, all nice and clean. And if we look at it from the other side, mounted in here beautifully. I get way better than this. And by the way, remember these were 68 microfarads. The originals had 75 microfarads. They're again giving up something. 100 microfarad here, gaining some capacitance in the power supply, which will be just fine. Okay, I pulled out these two here. Check out the leads on those things. Kind of crazy. At any rate, these are the original holes right here, the negative and the two positives. And if you notice, I bent these leads in just slightly inward, and then you can kind of fit these down in here. And if you'll spend a little bit of time working with it, looking from the other side, you can get this thing to fit down in there. Probably can't do it with one hand, but we'll show you when we get it in. And there you go. Wow, doesn't that look much cleaner than the kind of gobbled up mess we had before? And we've got the right size capacitors, and they're you know, made to last, got more voltage rating in some cases. I still got to replace these two here, and I got to solder this one in. Okay, at this point the power supply board's completely rebuilt. There's just about 3 components on here that I did not replace. Well, a couple of those diodes did not replace because they tested fine and weren't really worth pulling. There's a resistor back here, 2 resistors back here. But yeah, the mass majority of this board has been rebuilt at this point in time. All these 2 resistors here were still in great shape too. But we've replaced all the 3 of these orange drops, about 6 power resistors here relating to the power supply, and all the capacitors on this board for the most part. I'm pretty excited. This thing should sound much better now that it has the proper power supply set up in it. Okay, we pulled the 4 resistors, the one which was burned in half and cracked. I don't know if you can see it real easily right there, but it's cracked down the middle. And pulled those 4, and I've replaced it with the 4 precision resistors right here. And so now what I want to do, since I've done a bunch here, I want to power this thing up and make sure that I haven't got any issues back here on the back half. But I didn't want to do it until I replaced what I knew was a bad resistor. Everything else here looks physically fine. You know, I'll still need to test everything, and I'm certainly going to replace a lot of what's in here. But I just didn't want to go too far without testing this out, and got to get the tubes back in it as well. And talked to the customer last night, and they basically said, hey, go ahead and get 4 new tubes for this thing. So I'll have to go see what I've got laying around in here, and if I don't, then I'll have to order 4 of them. Good news! She's working well. Not detecting any heat back here on the capacitors. Nice and cool. Still got the whole front end to rebuild, but at least at this point I know the power supply rebuild worked out well. Alright, let's dive into the front of this thing now that we know everything back here is good. Okay, one other thing I noticed when I had it running over there is this bulb, and these things screw in. So you just unscrew it here. And this is a nice little bulb enclosure setup. And it is a GE387 bulb, and 28 volt bulb on this thing, 1 watt. And the way this thing works is, let's kind of hard to do here one-handed, but if you pull on it, the bulb here, you can see I'm pulling it out the end. It pulls out of the end of this little holder here. Tough to do one-handed, but that's what you get. You get this little bulb that slides in there, and this it's got a flange on the back of it. Any rate, I will tell you that AR wants $10 for one of these, plus about $7 shipping, so you'll have $17 in it. I was able to find some on eBay, a 10-pack for about $10, so got that, and we'll put it in here, and I'll have a spare for mine if I ever need one. And then this bulb here actually is tied to the outlets here. When you turn it on or off, it lets you know that you're controlling the switched outlets on the back. This is a 120 volt bulb, so it's a different bulb. Make sure you don't try to use one of these bulbs inside of here. Alright, and 7 hours into it at this point, because I started at 6 a.m. this morning and it's 1 a.m. now, or 1 p.m. We've now got all these capacitors in here replaced, all of the coupling caps throughout, use some pretty decent quality Solon caps. There's 2 of them down under here, one here, one here, one here, one back here. And then about a dozen resistors or so that I replaced. You can see I used a bunch of the 100K precision resistors as well as a bunch of the Dale resistors. But yeah, but some of the resistors here tested out fine. One good thing you can do is you can pull a tube, and about half of these resistors, one leg of it goes to a pin socket on the tube. So with the tube pulled, there's really no connection there, so it's easy then to check on the other side of the resistor, and then check on the side that's connected to the pin socket. And it's really easy to test the value of a resistor then and see if it's drifted or not. So far we're in good shape. Next, I'm going to clean these pots, and I'm going to get it back over on the bench and test it out, see how it's sounding. Alright, it's been about a week since last worked on this video, but in the meantime I've done quite a few things to the good old AR SP3 here. One, I've got the new light glowing brightly here on the front, as you can see. That's as simple as unscrewing that thing. It's in a little socket, and you put it back in it, the new one. And as you can see here, this little button here turns on and off this red light, and what that is to let you know that the outlets are on or not, and those are the outlets it's talking about. So you could take and plug your amplifier into those outlets and then control the on and off with it. I'll show you something I do though. Behind my bench here, there's a power strip made by a company called AAA, and they're about $35 on Amazon. And they come with it comes with a remote control. So basically, if I hit the on button, it turns on everything on my bench here, and if I hit the off button, it turns off everything on my bench. I like that thing a lot. So let's talk about what we have done here. I went ahead and replaced about another dozen resistors on this thing. I thought while I've got it on the bench, I might as well. So anything that had a precision resistor value to it, I've replaced at this point. And I've replaced a few of the carbon comp resistors that have drifted over time. They're kind of known for doing that. We've also put in the 4 new 12AX7 LPS tubes from Sovtech, and I don't know if you can see that on the side of it there, but I think they're the best tube out there for the money right now on the 12AX7 line. You get the long plates, you get kind of a heavy-duty mica standoff, so pretty rugged, and it's got the LPS, which stands for long plate spiral. It has a spiral tungsten filament in these things, which is really good to help against microphonics and whatnot. So let's see what else. Oh, we cleaned all the RCA jacks on the back. Everything's good there. You know, before we mentioned everything else, we've done all the recapping and rebuilding of the power supply boards, and as well as we've cleaned all these potentiometers at this point in time, so they're nice and clean. One thing I had thought about doing, because if you send this unit into AR, they will basically do a couple things. One, they will replace this entire power supply board with a new modern power supply. They will rebuild this board, and then they will put in it an Alps blue velvet pot right here. and they'll charge you about $1,300 for the upgrade, and there's no in between. You do it all or nothing. It's kind of a one-time shot thing. This is what an Alps Blue Velvet pot looks like. These things are pretty famous. They're usually about $25 a piece, maybe $35, and they're just a good smooth carbon wipe resistor. I mean a potentiometer. And so here's the deal. I reached out to AR and said, hey, do you sell a replacement pot for this, one of the Blue Velvets that you use in your restorations? And they said, yeah, it's basically $100 plus $9 shipping. Well, then I started reading on some forums, and you can basically take the exact same potentiometer, 100K gained pots, and you can basically get a Dremel out and whack off this little nub right here, as well as you got to grind down the entire edge around the back of this thing to make the shaft long enough. And if you do that, then it'll mount inside the unit, and you can kind of use it to control the volume, maybe a little quieter, maybe a little smoother. But honestly, this thing is great, the one that's in it. I've not had any issues. I've not hit any dead spots in it. It's just slick as glass. So I've been recommending to the customer, hey, maybe we avoid this buying one of these and hacking it up, or the $100 AR route. I just don't think it needs it, to be honest. Let's see. Let's see how this thing sounds. Actually, this is an album by a couple friends of mine. The band's name here is White Buffalo Woman, and this is their first full-length LP that they've done, and it's the first full-length LP I've done on my record label. I've done about 30 records thus far, and most of them have been 7-inch. This was my first full-length LP, but I think you will see here. Sounds pretty good. Could not be any happier. Oh, got the phone ringing. Sorry about that. That was Walgreens with a refill reminder. Alright, playing it through, and I used to take you over now to the bench and show you just a couple things there, and then we'll wrap this thing up. I'm a little frustrated. This is the 5th time I've made this video, this intro video. For some reason, I take the memory card out of the unit here, go put it in my PC, and I've been getting kind of file corruption issues. So I'm trying a different memory card at this time. Maybe we won't have the problem this time. Alright, it's Sunday morning around the 25th of September. And it's been about 5 or 6 weeks since I last left off on this video. I've had a lot going on, kind of changing day jobs. My grandmother passed away one weekend. Just a few things have gotten in the way, and I had to order some parts. So finally got back around to this thing. I'll tell you where I last left the video off. You know, the amp sounded amazing, the preamp. I was getting just a little bit of distortion on one of the channels at very high volumes, and on the bench. It was never something you could tell with your ears over there. And so I kept at it. A little bit of a perfectionist, especially around things I've got passion for. Ultimately, you can see here, I ended up replacing 111 parts in this amplifier. Many of which, like this one here, you can see it's just about burned in half. It's a resistor. Others which were like these types, these were just way out of spec. A lot of the old carbon comps, carbon comps are notorious for, as they age, the resistance just gets higher, and which causes all sorts of interesting things to happen to your circuits. You know, we had stuff that were just completely wrong, undersized and not right. We had tubes that were bad. And then we had components that were completely just not the right components, did not match the schematic whatsoever. And then in other cases, you know, like these, they matched the schematic, but we took the opportunity to upgrade them to some higher quality components, give things a little better sound. And then in other cases, like with these diodes, the ones that were in it just looked aesthetically horrible the way they were put in, and it was bugging me. So ultimately, we've solved all the issues we had. I will tell you something that was quite interesting as I got further along in the thing. Oh yeah, by the way, these things are horrible. Never use these wrapped little mica. They come in this color and green. Don't ever use those. One thing I found was the phono stage of this thing, which is made up of tubes V1, V2, and V3 right here. If you're looking at the amp's layout. It's extremely sensitive to the types of tubes that it likes. I kept playing around with these brand new 12AX7 LPSs, some brand new ones I bought. Never could get the phono section where I wanted it. I ended up with some old RCA black plate tubes in the V2 and V3 spot, and a Telefunken in the V1 spot, and turned out it worked out great in the end. But it was just some tube rolling I ended up doing to get the right sound I was after. A little bit of trial and error. I tried about 40 different 12AX7s in this phono front end. Everything else was sounding great. I was just struggling a little bit with the phono section, but in the end, I think we got it where we want it. One thing I will point out, and somebody called me out on it, and they were absolutely right. I was describing how this layout worked at one point in time, and I was doing it from memory without going to the schematic, and I kind of got it wrong. But the way this works is V1 is the first tube coming off of your pickup of your cartridge, and then it kind of feeds into V2 and V3 here. And so if you don't, you know, that's the phono plug is right here. If you don't plug into the phono plug, let's say the third one here, which I think is the tuner, if you plugged into the tuner or the spare input jack here, you would just feed straight in over here into V4. That's the first tube of the preamp section. And that's why they recommend tube V4 and V1 to be some high quality vintage, like Telefunken, Mullard, Siemens, something along those lines. Anyway, if you plugged into the tuner or the spare, it would just go through V4, V5, V6, and then out the output. So you'd really just be using those 3 tubes out of this whole setup. If you kick in the, you know, if you put it into the phono, then it goes V1, 2, 3, then 4, 5, 6 out the output. And if you happen to turn the tone control knob on, then you kick in V7 and 8, and they're only used if you kick in the phono, the tone controls. And you can kind of see that here on the schematic. These 3 are the first 3 of this little block right here is the phono. So if you don't feed into the phono, you're basically feeding straight into this section over here. You can kind of see the switches take you over here. So you'd kind of pick up V4, 5, 6, and then, by the way, you can see here on 4, 5, and 6, it picks up off of the cathode here of this tube and kind of feeds over and goes this direction and then comes over here to right here. It also feeds off the cathode of this tube straight on over up through this resistor right here, capacitor right here, and then down and over right here. So depending on whether you turn this switch this way or this way, you either pick it up right here off the cathode of this last stage of V6, or you pick it up, in this case, on the other side here where you've brought it through this circuit. And you can see the variable resistors. Let's see, one right here for the treble, right there, and one right here for the bass, etc. So hope that helps explain the circuit a little bit to you. You know, it's interesting. You know, when I kind of laid this out for people, and I do appreciate the person that called me out on it. They said, "Hey, you had a slight error in the way you were describing this thing." But you know, sometimes I have people call me out on stuff, and you got to kind of be there making these videos to understand what I'm talking about. But sometimes I'll point at something and I'll say that capacitor. And in my head, I said resistor, but it came out on the video as capacitor, and you saw me catch myself just a minute ago. You know, sometimes I'll have people post on my videos, "Hey, you called that one thing a resistor, but it's really a diode," and you know, in the back of my mind, I'm going, "Hey, I've been at this 30 years, and I'm restoring these things and making videos online. If you don't think I know the difference between a resistor and a diode, just cut me a little slack." Sometimes your mind and your mouth do not match up when you're making videos, because you got a lot going on in your head trying to think about what's next, if that makes sense. Okay, here is the final product, and it may be easier to point out what I did not replace at this point than what I did. All the phono stage was rebuilt. I did not replace these two resistors right here, two power resistors, as part of the power supply. They both tested well and were in great shape. Some of these old dog bone capacitors, I think there were 4 of those in it on this side, 6, I'm sorry, that I did not replace. They tested out well, and typically those things last forever. I did replace the ones, however, over here going around this first tube here when I was trying to chase down the distortion challenge I was having. I think that's it. Pretty much. I replaced pretty much everything else in this thing. Pretty happy with how it's turned out. You know, a good mixture of components in it. Power supply, super heavy duty. Could not be any happier with how this thing's turned out, both sonically, aesthetically, and mechanically here. Okay, one last thing I wanted to show you. If you remember, the bulb on the left hand side here goes in this socket, GE387. You can find those on eBay, various places. You can get about 10 of them for $10. This side though is an NE2 bulb, little neon bulb, inside of a package that'll mount in this. It's called a C9A if you ever need to order one. Those are about $5 each, but just wanted to show you the difference. Don't ever get these two backwards and in the wrong place. You'll end up messing something up inside of here, because this one actually runs 110 volts through this bulb, and this one's running something much less than that. Alright, final test on it. We've got it all set up here. I've been burning it in, as I've mentioned before, for hours. I'm on day 2 now of the final configuration and testing. I also made up the customer another set of old RCA tubes to send with him in case these two ever go out. To save them the trouble I went through of tube rolling and whatnot. I went through probably 40 or so tubes till I got just the right sound I wanted out of this thing. So sent him a spare set of those. I'll wrap this video up. This is a test pressing from an upcoming release I've got coming out. Good friend of mine, Johnny Walker, of the infamous Soul Dad Brothers. It's a solo record he's put together. Basically Johnny covering a bunch of old 78s he had in his collection, and I'm absolutely in love with this thing.
1, 2, 3, 4. Well, let me introduce you to my rocket 88.
Alright, we're going to call it a wrap. It's been a great fun video. Took way longer than I thought. Put a lot more time into this thing than I ever planned, but you know what? It was worth it to me. Sometimes, like especially when I own a piece of equipment, I want to become the master of it. I want to understand what every component in this thing is doing, and why the original designers maybe chose the values they did for it. So basically reverse engineered the entire circuit in my head to fully understand what everything's doing here. It helps you optimize what you're putting in here, etc. So really happy with how this turned out. Hope you've enjoyed the video, and more to come. I'm going to get around to restoring mine one of these days. Thanks everybody.